All right, ladies and gentlemen. Now, one of the things that I like about doing a YouTube live is that I don't know, it's a little bit easier to download the live after you've completed it, right? So maybe you won't be able to get it as soon as you have, completed your recording, but perhaps maybe 24 hours later, you're supposed to you know, you should be able to press download and it will be theirs. I mean, yours for the taking is what I meant to say. It will be there for you to retrieve, right? Anyway, yeah, yeah, I'm often dyslexic. So why don't we start the show? All right, hold on. You might want to give me a second. Wait, I want to see. Is this? Yeah, because sometimes the laptop can be a little shaky. Right. So I did this. I did this earlier. No, I'm hoping that even though it looks inverted, I'm hoping that on the live stream it actually looks normal. So let me actually check it. Oh, thank God. Yes, it looks the way it's supposed to look. Okay, good. So it looks inverted to me, but for everyone else, it looks, yeah, yeah. So you know what? No matter how them try to stop and flop the show, you don't need to cut anybody off. All you need to do is grow. That's all you need to do. Just grow. Just grow. Yeah, just grow. Just grow. Right? I never thought of doing this before, but I figured with a new backdrop, with a new, I guess a new location, right? Um, we're outdoors. A little bit outdoors. I'm under a tent, but still outdoors. I made this video and I'm charging my phone right now, so it's a bit techy. I would love to show you what the video looks like. I could. You know, maybe the next time I go live, because I have a library, I have a database of videos. We can go through that. We can go through that. Now, what I was doing here was I was trying to ask the question, did you know that trigonometry really and truly is algebra, right? Look at the indices is in there. Because when you raise cosine to the -1, it's the same as saying 1 over cosine. And if you multiply this by cosine, you're left with 1, right? This is the same as saying cosine raised to the 0. When you raise anything to the 0, you get 1, right? You get 1. I don't know if it's that obvious, but let's try this again, right? Let's try this again. So you have the cosine of theta, which is equal to a over h. And mind you, we could change this to anything we want. We could literally go to the tangent now. Let's do it with the tangent, right? So let's change this to a, change this to o, and change this to the tangent, right? Now, what would happen here is that this would become over a over here. And this would be over a over here. But now, these would have to become, so we'd have to do something different with that now, right? So let me get rid of that. Let me get rid of that. Right. So I will have to have a tan right here. Right? Let me look for, okay, good. I have something in blue. There you go. No. We would have to write a tan. Let me write it properly and correctly. we'll have to write a tan to the minus 1 here and a tan to the minus 1 here. Right? So it's like you're multiplying 1 over tan by this, and tan over tan would leave you with just that. So it's like you're dividing both sides by tan. That's really what you're doing. And then, of course, this will cancel, leaving you with just that. And then you would write your tan to the minus 1 of O divided by A. And this is relevant when you have the sides, but you don't have the size of the angle. This is how you find the size of your angle, depending on which ratio you're using, right? So, yeah. Now, I am hoping that the quality of the video isn't too bad. I mean, maybe my lighting is a bit weird. I don't know. I don't know. I don't know. I guess I'll be able to double check that when we're done here. But yeah, and the beauty about this is that we did it with the cosine, we did it with tan. The same thing would happen for sine, right? And there was something else. I don't remember if I'd shown that, but of course, okay. You have the sine rule and you have the cosine rule. The conditions are very easy to remember. 2 sides, 1 angle, or 2 angles, 1 side for the sine rule. And then, of course, in the event of a obtuse triangle or a non-right angle triangle, when you're using the cosine rule, it usually means that you have 3 sides with no angle or 2 sides with the included angle, right? All right. Give me a second while I attempt to plug out see if I can plug out this laptop a little bit. I hope I'm trying not to plug out the USB camera in the process. Hold on. Give me that. There we go. All right. Yeah. No. So yeah, this works for, regardless of what trigonometric ratio you have. Yeah, this will be fine. Oh, yeah, I should have changed this to O and A. Right? So in this case, you'd have O and A. And of course, you find O by multiplying A by both sides. So O would be A times the tangent of theta, right? So you have that. And then, of course, when you have that, you can use that to find A. You divide both sides by tan of theta. So, yeah. I can always do it as well, right? I mean, I can show better than I can tell. So why not? I show better than I tell, right? Show better than I tell. So let me see. Right. Let me multiply. So A here, and then A here, right? So that is how you end up with O. So you end up with O by doing this. So O is achieved by doing that, multiplying A by both sides. Now, if you want A by itself, how I see it is whatever is not in blue, you divide everything else. So let's just divide the left by this. All right? We'll divide that. And of course, we divide this by that. So now, due to the cancellation, we will have A being equal to O divided by tangent of theta. Right. No, wait, give me a second while I try to adjust the fan. Let's see what I can do. I want to move the fan so that it's not affecting the laptop itself. Right? It's rather not have the laptop shake, you know? All right, there we go. Yeah. All right. So yeah. Yeah. So those are the two considerations you need to have, right? We found the O and we found the A. And then of course what we did before, we found theta. Theta is when you want to find the size of the angle, right? You want to find the size of the, so this is when you have the size of the angle, right? So whether you have A times tangent of theta, you have the size of the angle already, that will help you to find O. Or to find A, you do this, you already have the size of the angle. So all you have to do is replace this with whatever number is there. So if it's 31, 67, 49, whatever it is, you just put that in there. Right? So you have that. So yeah, that's yeah. No, I would of the cosine rule, right? Here's what I would do. Imagine this if you would, right? Clearly not a right angle triangle, right? Now let's have a little A, a little B, and a little C. But more importantly, this C points to big C, this B points to big B, and this A points to big A. Now, the reason why that is important is because you need this understanding to deal with the cosine rule whenever you do see it, right? So you will have big B in the middle of little a and little c. Big A in the middle of little c and little b, right? But it really depends on how your triangle is labeled. It's not always like this. It just depends on what labels they give you and all of that. And a lot of times in the CSEC question is usually in the form of bearings. So it's never really that simple. They usually give you the diagram or they ask you to draw it, but most times they give you the diagram anyway, right? So what do we do? It could be little a, it could be little b, it could be little c. Do we start with the little a? Let's start with little a. So we have little a squared. But then you're going to have little b squared plus little c squared, right? So think of this almost like Pythagoras theorem, right? Almost, right? Almost like it, right? So you need little b squared plus little c squared. And it makes sense. Yeah, it makes sense. Because the angle between the little b and the little c is going to be big A. And that's why you have the big A at the end. Anyway, so what comes next is a thing called minus 2 times the product of B and C. So always think about B, C, and then B, C again. So you're going to have minus 2 times B, C. Then now you're going to have big A at the end. So whatever you have out here, you're going to have the capital cosine of that out here, right? So therefore, this is how you would find the side of little a in the event of doing the cosine rule. And of course, it can be rearranged depending on what you're looking for. So for example, if we're looking for little b squared, it becomes little a squared plus little c squared minus 2ac, the cosine of big B over here, right? So that is how you would that's how you'd find little b. Now little c squared is equal to little a squared plus little b squared minus 2ab. This becomes capital over here, right? Cosine of the capital. Yeah? I might be tempted to see if I can watch the live from my other phone. So let me turn on my Wi-Fi. I have no idea what it's going to look like. So it'd be nice. It would be nice. Let's go. Let's touch the. All right. So let's go. All right. Wow. Hold on. That looks a lot better than what I'm seeing. That looks so much better than what I'm seeing. Because what I'm looking at looks kind of crazy. Oh man, this look amazing. This look amazing. Let me see if I can show that to you. I don't know. I don't know. Ah, it look good. It looked good. I wasn't expecting it to look that good. So now, okay, it is possible for you to zoom in while you're watching the live. So it's possible. So if you're touching it, you can always you can always zoom in. Oh my Lord, hold on. This fan decided that it's going to spin, and that's why the laptop shaking again. We fix that. Yeah. So I'm pleased. I am pleased. All right, hold on. I wrote that a little bit too small, you know? A little bit too small. So it's AC, AB, right? Yeah, right? I don't know. Let me have a look at my phone. Let's see how good it looks. All right, that don't look too bad. Yeah, that don't look too bad at all. Yeah, yeah, yeah. So I am going to try my luck with this until I get my original whiteboards back, right? That's what I'm going to do. But yeah, so obviously, sorry, yeah, I almost knocked over everything. All right, so this is what happens when you want to find the side. Yeah, when you want to find a missing side, you would use little b, c, and big A. Little a, little c, and big B. Little a, little b, and big C. Right? And that makes sense, right? Because little a, little b is here, and you use big C over here. So it follows the Oh. So even when you draw the diagram tells you what you need. What if you look at little a, big C, little b, that's what you need. You don't need anything else. Here, little a, little c, and big B. That's what you need. Little b, little c, big A, that's what you need. And each time it proves itself right. So I didn't notice that before. At least not diagrammatically anyway, right? So now there is another way to look at this. So you know what I go do? My rubble so I apologize if we're enjoying the quality of what we have here. So let me just get rid of that. Get rid of that for a minute. Right? I mean, you know, I've already made my point here, right? Trigonometry is algebra. We know this. We know that now. All right, we know it now. We don't have to guess. We don't have to guess if it is. We know it is. Right? We know it is. So we have little a, little b, little c. Right? So we have little b squared plus little c squared. Minus 2bc. Minus 2ac minus 2ab. Big A over here, big B over here, big C over here, right? Put the cosine here, cosine over here, cosine over here, right? Letter A squared plus letter C squared, so A squared plus letter B squared, right? So let's bear all of that in mind. I could redraw this over here. Right? So let's put big B, big C, big A. This points to the little c, points to the little a, points to the little b. Just setting it back up. Yeah, so all of this is in relation to the all this is in relation to the cosine rule, right? So let's remember that. Yeah. All right. So we have this. This helps us to find the little a when it's missing, the little b when it's missing, the little c when it's missing, right? Now I try to make all of these smaller than the capital over here. All right, hold on. See? All right, I'm going to have to turn off his fan. This is driving me crazy. Give me a second. Hold on. Yeah, I'm hoping that it just stays in place. Okay, hold on. Let me turn it off for a minute. So really trying with this thing. Oh, I see what happened. All right, let's hope that. I'm hoping that it doesn't move too much. I'm hoping. All right. All right. Let's try that again. Let's try that again. Okay. So where was I now? Cosine rule, right? Watch out. Sorry about that. Trying to be. The feed is delayed. Oh, no. I don't think you can see that. Yeah, maybe. Okay. All right. So where was I? I wanted to explain how you would find the angle of A, the angle of B, and the angle of C. Now, what you do for one, you can do for the rest. Now, let's see how we will do that. We want to change little a squared, right? Want to change this. But how would you do that? How would you actually change this just to find A? Well, what I do for people is, I tell them this. Imagine, just so that your life is easier. Imagine if you have little a squared equal little b squared plus little c squared, right? Minus, let's call this, let's call all of this L. Let's just call it L. What would you have to do in order for you to find L? You'd have to add L over here and L over here. So if you add L here and L here, you'd end up with L plus a squared is equal to this, right? You know, humor me, right? So L plus little a squared equal b squared plus c squared, right? Minus L plus L, right? Now, obviously, that would cancel, leaving you with that, right? Now, how would we get L by itself with minus a squared from the left and right? So we would minus a squared from here and minus a squared from here. So when everything is said and done, well, you would say that the L is equal to b squared plus c squared minus a squared. Now, here's why this is nice. Now, you can take the L and change it back to all of that. Yeah? 2BC cosine of A. So why don't we change this back to this? So 2BC cosine of big A is equal to this. Right? So give me a second while I double check this. Yeah, that's not terrible. It's not terrible. It's not terrible. Maybe I might want to put the table a little closer so that you can see the board a little better. Maybe. Maybe I'll, all of this is a test run for me. So, yeah. So here we are, right? So this is your first step to rearranging it, right? This is your first step to doing that. Now, let's focus on what's to the left of cos A, right? Let's just focus on that. Normally while I'm doing this, I take pictures, so maybe I could do that. Oh, dear Lord. I've forgotten that I turned off my tablet. Yeah, that's fun. Oh man. Okay. All right. So I'll turn off the tablet. Let's see. Okay. You know what? It's fine. Oh, that's Sebastian Angus, by the way. Uh-huh. All right. There we go. Yeah. Wow. Wow. All right. There we go. The quality isn't too bad, but of course, yeah, I might need to let's do that. Yeah, it's kind of hard for you to see that. At least even hard for me. Yeah, yeah, it's kind of hard to see that. Kind of hard, but you know, it's fine. It's fine. Tell you what, any screenshot that I do of the live, I'm going to put those screenshots on my Instagram and my TikTok. All right, so you see how everything is related. If you want to see any of the screenshots of anything that I've done, because I mean, I could clearly put them up as posts as well. So I can put them as a post on YouTube as well. Because once upon a time, posts did not exist for YouTube. So I'm going to utilize that feature as well. I mean, why not? Why not? But yeah, this is a good looking picture. Very good, right? So now that we're here, I'm going to erase a bit of this, right? Erase a bit of this. Right? Going to erase a bit of it. So where we're at now, we're at the point of 2 times BC or 2 BC. Cosine of big A is equal to little b squared plus little c squared minus little a squared. Right? Let me remember to write the red. There we go. No. We have this, we have this, we have this, we have this, we have this. Want to get rid of this. We're going to divide both sides by everything to the left of the cosine. So 2bc, we'll put that down here. But what we do to the left, we do to the right. Right? There you go. So this is the second major change that we make to this, right? There's one more step. One more step after this. So the question is, what is that step? What is the step that you make after this? What's the step? Remember what we did before? We had to multiply this cos by cos to the minus 1. Just like what we did before. Right? So imagine all of this in bracket. But what goes before it? What goes before it is COS raised to the minus 1. COS raised to the minus 1 times the cosine of A. Ah, right. So let's have a look at that too. Right. So now, what do we do? Well, anything raised to the -1 multiplied by. So in other words, this is raised to the +1. This is raised to the -1, right? It's raised to the -1. This is raised to the +1, right? 1 minus 1 is 0. Anything raised to the 0 is 1. 1 times A is A. And that is why you end up with this. You end up with just A. Right? Hold on. I want yeah, I want it to be very clear that that was crossed out. And so now you can just yeah. If we're being real, what is actually happening is that 1 is being multiplied by A. Right? And 1 times A is just A. Just like 1 times Bossman teaching is just Bossman teaching. See? Yeah. So let's see. I have my screenshots. So we have 1, we have 2, we have 3, we have 4. And there we go. So here's the final one. Yeah. Here we go. Oh, that's my eye. That's my eye right here. All right. So I feel like now, if you can manipulate your equations when you get to seeing the questions in any exam situation, then you should be fine. Right? You shouldn't have to worry too much. Right? Don't worry not. If you're wondering what I'm looking at my phone. I'm looking at my phone. All right, sorry. I'm distracted. My marker fell. Let's see. Marker fell. All right. So I hope that we had, you know, hope we didn't have too bad a time. Right? I am genuinely surprised at the quality of the picture. Right? Quality of the camera. Surprised. Because what I'm looking at, you know, it looks better. It looks better on a device. So a little bit distracted because what I want to do, I want to actually check it out on this phone as well. So let me do that. Right? Did I turn on the volume? Yes, I did. I turned it down. Oh, okay. Oh, okay. I'm sorry. I pressed play. Oh, okay. I thought I did. Oh, I want to see the. Why can't I see the. Oh, wow. Hey, it look even better over here. But you see, you still can't see that. Let me see. Yeah, this don't look bad at all. This don't look bad. This does not look bad. So it doesn't look bad at all. Yeah, I'm content. I'm content. It's a good test run. It's a very good test run. And the good thing about this is that what I can do is I can do it on YouTube first and then just drop it as a replay in Facebook. You know? Not to say that I won't, you know, I can go a bit of an extra mile, but it depends. Like, you know, if I have, what's the word now? An audience. I have an audience and people are asking me questions, I will answer the questions once it's relevant, you know, I can do that. But this is a good little test. I do like this. I do like this. I'm applauding myself. I'm applauding myself. Yes. Use what you have, ladies and gentlemen. Use what you have. Don't make anybody stop you. Oh, they took your calculator? Worry. I don't need the calculator. Who told you I needed the calculator? This is what happens, you know. You see it, you know, it's a beautiful thing. It's a beautiful thing. So I'm done for now. I will use this as a means to, you know, maybe invite parents. I have an idea. I have an idea. But the word I'm looking for is limited space. Limited space, limited time. So you have a limited time offer, but there's also limited space. You know, because I'm thinking I could say, huh, I will do this on one condition. So for example, if I say to you, what if you could work with me online for free? If you're interested in that, you press the WhatsApp button. You know, no, I would love to show you here, but I'll make a video about that. I'll just make a separate video for that. And then, of course, maybe play it in that style too. Anytime I go live, I will do videos that I've already, yeah, just we'll do that. This is a nice test run. So if you didn't feel too lost in my presentation and you don't mind working with me online, possibly face to face if you live in the area, this is what it's like, right? So this is what I'm literally doing this from Zoom. So a lot of my classes will look like this, right? Good thing is I don't have to worry about data. Don't have to worry about data using Wi-Fi. So yeah, rejection is a blessing. Take every rejection as a blessing. Yeah, man. Every rejection is a blessing, believe it. Because sometimes rejection is God's protection. Sometimes. So anyway, thanks for helping me to stay consistent. As I always tell you, honor your commitments. We can leave it at that. So, oh, sorry. What was that? All right, we had to end it on a blooper. Yeah, it was so perfect. And something had to happen. But you know what? It's fine. Not go flat my show. Again, thanks for helping me to stay consistent. As I always tell you, honor your commitments. Right?